All right, sample problem 5.8 says find the density in grams per liter of CO2 gas and a number of molecules per liter. All right, and we have some conditions. A says at STP. So let's talk about that first. STP stands for standard temperature and pressure. And any time you see STP, standard temperature, let me write this down. Standard temp is equal to 0 degrees C, which is also equal to 273.15 Kelvin. Standard pressure is equal to 1 atmosphere, which is also equal to 760 torr. Okay? So those are the conditions. So they want us to find the density in grams per liter and the number of molecules per liter for CO2 at standard temperature and pressure. All right, so remember, PV equals nRT. That's an equation we have, right? And density, remember, density is equal to mass over volume. So those are the two equations that I have available to use for these types of problems. So how am I going to get this? Now the volume is maybe not going to be so bad, right? But if you notice, right, PV equals nRT, that tells me volume and number of moles. So we also have another equation that I haven't really mentioned before. But first, let's talk about how it's derived. The number of moles of anything is just equal to its mass divided by its molar mass. Right? That's how we get the number of moles of things. So what if I plug that into PV equals nRT? PV equals the mass divided by the molar mass times RT. And now I rearrange to get mass and volume, right, because density is mass and volume, on one side. So I can get the mass up top and the volume down on the bottom and do some algebra here. So mass divided by volume then would equal the pressure times the molar mass divided by RT. Right, so density is equal to mass over volume, which is also equal to the pressure times the molar mass divided by RT. And we have all those things available to us here in this problem, right? The pressure is 1 atmosphere, because they said it's standard temperature and pressure. The molar mass of CO2, I've got 1 carbon, 12.01, plus 2 oxygens, all right? So the molar mass from the periodic table for carbon dioxide is 44.01 grams per mole, divided by R. R is 0.0826 liters times atmospheres, divided by moles times Kelvin. I've got to get some more room here because I'm out of room. And then that gets multiplied by the temperature. Right? The temperature is also on the bottom. And standard temperature is 273.15 Kelvin. All right, so let's check our units first. Got atmospheres in the top divided by atmospheres in the bottom. Now I'm going to look, I've got per mole, right? I've got Kelvin in the bottom of the units for R and Kelvin right there. They're going to cancel. And I'm going to be left, check it out, with grams and liters. So grams in the top, liters in the bottom, which are the units for density, mass divided by volume. All right, so now let's do the math. 44.01 divided by CR 273.15. So I got that the density, the density is then equal to 1.95 grams per liter. So that's A part. We put A there. Now, B part says at room conditions, so 20 degrees C and 1 atmosphere. So room conditions and standard STP are different. Be sure you understand that, right? The temperatures are different here. So let's see here. We're going to use our same formula, right? Density is going to be equal to the pressure times the molar mass divided by RT. All right, so our pressure says that it's 1 atmosphere for room conditions times the molar mass. That didn't change, right? It's still 44.01 grams per mole. Divided by R. R is a constant. It didn't change. Times our temperature. Our temperature did change, right? It went to 20 degrees. So that's going to be 293.15 Kelvin. Right, we have to convert that to Kelvin, remember. Let's check our units one more time just to be sure. I've got atmospheres, atmospheres, Kelvin, Kelvin, mole, mole. I'm going to be left in grams per liters. All right, so let's do our math now and see what this new density is going to be. 44.01 divided by R times 293.15. All right, so I got the new density then at room conditions is going to be 1.82 grams per liter. So what does that tell you, right? Density is dependent upon temperature. That's the only thing that changed here was temperature. So that's going to be important.